Okay, so in this video, we are going to analyze this truss. Okay, we are going to analyze this truss. So in stiffness matrix method, we divide into 3 topics. The first one, the first one is truss, followed by beam, followed by frame. Okay, so this is actually new topic. This is new topic because we don't have to take calculate reaction conventionally. So what we are going to do is we will use formula, the stiffness matrix formula to establish stiffness matrix for element, and from that we will continue to establish the structure stiffness matrix. So truss has structure stiffness matrix, beam also, and frame also. Okay, the procedure will be the same. The step A, B, C, D the procedure will be the same, unless the formula different, because in calculating stiffness matrix for truss we have to consider the axial rigidity EA. And when we analyze beam, we have to consider the flexural rigidity EI. And when we analyze frame, okay, we have to consider both EA and EI. Okay, that's what dalam textbook. So you can find this stiffness matrix under 3 main topic, chapter number 14, chapter number 15, and chapter number 16. Discussed in 3 different topics. So most important thing is degree of freedom. You have to understand about the definition of degree of freedom, and each type of structure, truss, beam, and frame has their own degree of freedom. Okay, for example, truss have 2 degree of freedom per node. 2 degree of freedom per node, beam has 2 degree of freedom per node, and frame has 3 degree of freedom per nodes. Okay, so detailed explanation about node identification, about element, degree of freedom, the appendix as well has been discussed. Ada dalam saya punya video, so please watch. Okay, so the idea is like this. So we are going to analyze structure. So what we get is the structure. So in stiffness matrix method, what we do is we have to divide the structure into element. Because when we start analyze structure by forming what we call as stiffness matrix for elements, stiffness matrix for member. Okay, so ada word tu dalam textbook, so please read the textbook. Textbook pun ada dalam your OneNote. Okay, we have to divide the structure into a series of finite discrete elements. So we have to analyze, for example, this truss. So truss is a structure. So we analyze this by analyzing element number 1, element number 2, and element number 3 separately. And after that, we will combine and we will get what we call as structure stiffness matrix. When we form the element stiffness matrix or stiffness matrix for member, okay, we call it as K1. This is stiffness matrix for member number 1, element number 1. We have to produce K2 stiffness matrix for element number 2, and we have to produce K3 stiffness matrix for element number 3. Okay, and from this diagram, we can see that there are 3 elements. Okay, and in stiffness method, we will normally call member as element, not member AB, member BC conventionally. But we use numbering to represent element. We will use numbering to represent nodes. Okay, nodes is join A, join B, join C. We change to numbering as well. We call it as node number 1, node number 2, node number 3, and so on. Why we need to do that? Because stiffness method is actually the theory behind structural engineering software. So it means that when we analyze, for example, building in software, in structural software, we will model the building, and the building that we model normally has 1,000 elements. So that is why we don't use A, B, C. We change it to numbering. So this is the basic. So actually there are some advantages compared to flexibility method. Okay. One of it is we can use stiffness method to analyze both determinate and indeterminate. If in flexibility method we use to calculate reaction only, we cannot get displacement using flexibility method. But in stiffness method, advantage number one, we can use it to analyze both determinate and indeterminate. That is number one. We can use it to analyze both determinate structure and indeterminate structure. That is advantage number one. Number two, using stiffness method, we can analyze all displacement, reaction, and internal forces using only one method called stiffness method. So we can get displacement, reaction, and internal forces directly using stiffness method. That is advantage number two. And this is actually the method okay, that is used worldwide, yeah. Worldwide. So, and you can also find this method in finite element method. So stiffness method is also known as finite element method. Cuma for stiffness method CS 521 ni under this course, we will focus on the global coordinate system only. Okay, so we will analyze this thrust. Okay, basically soalan macam ni lah. So you will be given node number, element number, degree of freedom. Sometimes is given, sometimes is not given. Okay, but before you can start analyze element stiffness matrix, there are 5 things that you need to put into diagram. 5 things. Okay, 5 things. Number one, you have to make sure that the diagram has node number. Number two, you have to make sure that the diagram has element number. Number three, you have to make sure that the diagram has degree of freedom label, which we written according to unconstrained and constrained system. Number three. Number four, we have to make sure that in the diagram we have to have the arrow which is parallel with all element, all member, arrow, and the arrow we can put in any direction that we like. And number five, we have to make sure that in the diagram, okay, each node have coordinate. So step yang we are going to do after this is actually the real step behind structural engineering software. Okay, so we have to make sure that in the diagram, node number, there are node number 1, node number 2, node number 1, node number 1, node number 2, node number 3, node number 4. And node number in the diagram normally sometimes is written in circle. Okay, node number. It represents join A, join B, join C. Okay, that is for node number. Okay, beside that, we have element number. Element number, and element will be labeled by number, okay, in the box. Okay, like this. 1, 2, 3. Okay, that is how we write element number. And element consists of 2 nodes. Element consists of 2 nodes, and each element has near and far end. Each element has near and far end. How we determine near and far end is by looking at the arrow that we put. Okay, node number done, element number done. Okay, degree of freedom label, which we will label according to unconstrained and constrained. Sometimes you will get question which DOF is not given. Means that you have to label the degree of freedom. You have to label the degree of freedom. Degree of freedom in trust is in X and Y component. This is for trust in X and Y component. Each node. So this is 2 degree of freedom per node. It means that if in this trust there are 4, 1, 2, 3, 4, there are 4 nodes, it will produce 8 degree of freedom. So this trust has in total 8 degree of freedom. 8 degree of freedom. Okay, because we have to apply 2 degree of freedom per node. So in total, we got 8. We got 8 degree of freedom. And you have always to apply the degree of freedom in this direction. You cannot change the direction. You have to follow this direction. It is compulsory. Okay. And next one is, okay, we have to label according to constraint and unconstrained. Constraint and unconstrained. Constraint refers to support. Constraint refers to support. Pin support, roller support, fixed support, that is constraint. Okay, so we have to divide. Normally, what I will suggest is when we have structure, okay. So unconstrained and constraint ni, unconstrained and constraint. So constraint basically is refers to the support, yeah, support. It is sometimes called as boundary condition. Boundary condition. In software, you will condition, boundary condition. Boundary condition. In software, you will find support called as boundary condition. Okay. So we will label number 1 must be started from unconstrained. Label 1 to 8 because they are 8 kan. 8 degree of freedom. So we will label 1 until 8. 1, 2, 3, 4, 5, 6, 7, 8. And we will label start from unconstrained. Unconstrained dulu. Then only followed by constraint. So how to identify this? How to identify this? We just need to look at the support. Okay, from this, there are 3 pin support. There are 3 pin support located at node number 2, node number 3, node number 4. There are 3 pin support. And from the support, we know that there are 6 degree of 6 unknown reaction. From support, we know that there are 6 unknown reaction. And 6 unknown reaction is equal to 6 degree of freedom in constraint system. In constraint system. In constraint system. So if there are 6 which is located in constraint system, remaining is located in unconstrained. Unconstrained. So basically what we do is like this. We just sketch the structure. Divide into 1 is unconstrained, 1 is constrained. One is unconstrained, one is unconstrained, another one is constrained. Then at support we will put since spin has two unknown reaction in X and Y, so we will put 2 2 2 like this, 6. And sorry, terbalik. In constraint. Okay, 6 degree of freedom in constraint system. This is constraint, so we will put 2 here, 2 and 2. So 6 means that this one is 6 degree of freedom, equivalent to 6 unknown reaction. 6 unknown reaction. So remaining 2 will be put in unconstrained system. In unconstrained system, so this is 2 degree of freedom. So total will equal to 8. Okay, when we label, we will start from unconstrained 1 2 1 2, then continue with constraint 3 3 4 5 6 7 8. YZ, XY, XY, XY. X first, XY, 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 3 4. So 1 2 3 4 5 6 7 8. So that is why we get like this. And in this question, degree of freedom is also given. Okay, degree of freedom is also given. Okay, done. About the degree of freedom. Degree of freedom done. Okay, arrow. Arrow, we have to check either the arrow is given or not. If it is not given, you have to put the arrow which is parallel. The arrow which is parallel to the member. Parallel. Okay, parallel to the member. So we have arrow at element number 1. Okay, from 1 to 2. And we have arrow ni for element number 2 from 1 to 3. And we have arrow for element number 3 from 1 to 4. And why arrow is important? Because from the arrow we can identify which is near end, which is far end. We have to identify near and far end, from the arrow. Near and far end from the arrow. And we will also label degree of freedom in matrix using the arrow. Okay? Near and far end. One element. Okay, this is the arrow. One is near node, one is far node, and arrow is always going towards far end. When we put, okay, 1, this is, for example, this is 1. This is 2. This is 3, for example. So by putting arrow like this, it shows that 3 is far, 2 is near. Because the arrow is always going towards far end. If we change this direction, it will change. 2 become far, 3 become near. And we can put the arrow in any direction that we like, doesn't matter. Okay, so this is about the arrow. Okay, arrow. So arrow is given, so we just follow that. Okay, next is coordinate. So coordinate, we have to label XY. And we will use this coordinate. Whenever we calculate CX and CY, or lambda X and lambda Y. CX and CY or lambda Y ni is actually the unknown that you have to determine. In order to calculate K. And CX, CY ada dalam appendix. Okay, dalam appendix. And if we identify near and far end based on the arrow that we put, so it is much more easier to identify CX and CY. Okay, so we have to put coordinate. So when we want to put coordinate, we have to choose one as origin, choose one as origin. So let's say this one as origin, 4 as origin. So based on this origin, we will label. We will label the others. Okay. So node number 1 will be 4, 3. Node number 3 will be 0, 3. And node number 2 will be 0, 0, 7. Okay, for 3, 0, 3, 0, 7. So coordinate. So then only we can start analyze this. Analyze Cx and Cy to find Cx and Cy, and after that we will establish the element stiffness matrices. Okay, yang ni belum start langsung anything. Okay, the first step is to calculate the element stiffness matrices. Element stiffness matrices. I have done one example this morning. Please watch that one also. Okay, please watch that one also. So different example. Okay, so we have actually appendix is given in the textbook, and appendix I will put appendix later on, and you can also find appendix in past year's exam papers. Okay, this is appendix. Okay, for the truss. Okay, this is K that I mean. Okay, this is K. It is member stiffness matrix or element stiffness matrix. Okay, it will be depend on the A, E, and L. Cx and Cy. Cx and Cy will be determined based on coordinate tadi tu, coordinate Cx and Cy. And based on the new appendix, Cx, Cy tu is changed to lambda x, lambda y. Because some ada certain buku pakai lambda, certain buku pakai Cx and Cy. Doesn't matter. Both are accepted. Okay, so this is the formula. This is the formula. So each K, we will get to 4 by 4 because one element near and far. Near has 2, far also 2. So for one element, dia memang akan dapat 4 by 4 matrix. 4 by 4 matrix. Okay, 4 by 4 matrix. So this is the formula. And inside this formula, actually, this 4 value equal to this 4 value. Okay, and another one is this equal to this. And actually all are the same except yang the green color tu semua letak negatif. Okay, so it is quite simple formula, and you don't have to remember because this will be given. Anyway, doing this for two or three times you will remember as well. Senang je formula ni. Okay, so go back to this. So since we have 1, 2, 3 elements, so I want to summarize Cx and Cy in table form. I want to summarize Cx and Cy in table form. Okay, we will start with element. And then L. Okay, we have Cx and Cy. Cx and Cy. So Cx and Cy. Cx and Cy. 3 element. We have 3 element. We have element 1, element 2, element 3. For element number 1, 4 and 4. So please calculate hypotenuse 4 ni. 4 dengan 4. Hypotenuse dia. Please calculate. Berapa hypotenuse? Horizontal is 4, vertical is 4, hypotenuse
5.66.
5.66 kejap. Okay, this is, okay, 5.66. Okay, element number 2 is 4 meter. Element number 3, 3, 4, 5, 3, 3, 4, 5. So this is 5 meter. Okay, Cx and Cy. Okay, in order to calculate Cx and Cy, we have to refer to the coordinate. Okay, for Cx, look at x coordinate. For Cy, look at y coordinate. Cx, look at x coordinate. Cy, look at y coordinate. It is far minus near. Far minus near. So that is why arrow is important. For example, for element number 1, element number 1 consists of node number 1 and node number 2. Node number 1 and node number 2. Okay, node number 1, node number 2. Arrow. So from this we know that this one is far. Okay, this one is near. Okay, so to calculate Cx, please look at the x value far minus near. X value far minus near, we have to divide by L. That is formula for Cx. It is far. What is the value for far? Far x. For x. What is the value for far x? Look at node number 2, because node number 2 is far. We define based on arrow. So what is x coordinate for node number 2? What is x coordinate? Yes, it is 0. So x coordinate for node number 1?
4.
4. So it is 0 minus 4. We have to divide by L. Okay, please calculate 0 minus 4 divided by 5.66. We get negative.
Negative 0.71.
707 ya? Okay. Okay, what about CY? CY, look at Y coordinate. Look at Y coordinate. Y coordinate at node number 2. Y coordinate at node number 2. What is it?
7.
7. So it is 7 minus 3. 7 minus 3. 7 minus 3, right? Okay, 7 minus 3. It is 7 minus 3 divided by 5.66. It is positive. Okay, so these two are CX and CY for element number 1. Okay, repeat the same for element number 2. Element number 2, it is 0 minus 4 divided by 4. We identify from the arrow. 3 is far, 1 is near. 3 is far, 1 is near. So it is 0 minus 4. 0 minus 4 divided by 4. So we get negative 1. And then it is 3 minus 3. It is 3 minus 3 divided by 4. Horizontal element memang CY dia 0. Kalau vertical element CX dia 0. Okay, so this is 0. Okay, what about element number 3? Element number 3, look at the arrow. 4 is far, 1 is near, so it is 0 minus 4 and 0 minus 3. 0 minus 4 divide by 5 and 0 minus 3 divide by 5. 4 and 3. Okay? Divide by 5. Okay, it is negative 0.8 and negative 0.6. Okay, negative 0.8, negative 0.6. Okay, so from this, we will now substitute into formula. Substitute into formula. So this is the formula. Okay, this is the formula. Okay, for K1, we will use Cx negative 0.707 and Cy 0.707. Okay, substitute and divide by L, then we will get K1. K1. Okay, this one you just refer to the formula, calculate on 5.66. 0 negative, it is negative 0.707, negative 0.707. Okay, you can check the answer. Okay, I have set the formula and I have got the answer now. Okay. Okay, you just need to substitute all the value into the formula ni, into the formula, and you will get the answer. Okay, so K1, after I put into the formula, so I get it is AE constant, so remain AE outside the bracket. So we get Cx square divided by L equal to 0.088. Okay, you can also check. Okay, please recheck. Cx square divided by L. Cx square means negative 0.707 square divided by 5.66. We get 0.088. Okay, so kena fill in all this lah. Fill in all this. Okay, for the beginning, you will find that yang ni macam slow je nak buat kan. But bila Wi-Fi pun problem. Tiba-tiba hilang. Okay, okay. So continue. So just complete this matrix. So this one will be negative. Negative. Okay, that is why arrow is important. CX, CY is important. Lupa letak negatif. So yang ni semua negatif. Negatif, negatif, negatif. This one also negative. Okay. So this is K1. This is K1. K1. Okay, then continue with K2. Continue with K2. Okay, K2. K2, CX and CY is K2 length is 4. Length is 4. CX is -1. CX is -1. CY is 0. Okay, so it is 1 square divided by 4. 1 square divided by 4, so we get 0.25. 0.25. 0.25. Anything paired with CY will be 0.25. 0. And since this is metric, so it has metric characteristic, it is symmetry. Metric characteristic. So this is 0, 0, 0. Zero. Zero. This one is 0.25 and 0. Okay, so this is K2. This is K2. Okay, and we will do the same for K3. Okay, substitute L, CX, and CY. This is K3, yeah? K3. Okay, and K3, length is 5, -0.8 and -0.6. Length is 5, CX -0.8 and -0.6. Okay, so CX square divided by 5 is equal to 0.128. 1 to 8, 0.1 to 8. Px Cy divided by 5, 0.8, 0.6 divided by 5 is 0.096. Okay, this one is same but negative 1 to 8 and negative 0.096. Okay, it is symmetry. One to 8, 0.96. Okay, Cy square divided by L is 0.072. Okay, so this one, no need to calculate anymore because it will be the same. So this one, this 4 value equal with this value. Okay. Okay, 1 to 8. Zero 0.96, 0.72, 0.96, 0.96, 0.072, negative 0.096, and negative 0.072. Okay. So we have K1, K2, and K3. But this is not finished yet. This is not finished yet. This is the stiffness matrix for each element. We call it as element stiffness matrices. Element stiffness matrices. We call this as element stiffness matrices. We calculate based on the global coordinate system. Okay, but this is not finished yet. This is not finished yet because we will produce the structure stiffness matrix by combining K1, K2, and K3. By combining K1, K2, and K3. So in order to combine all these three element stiffness matrices, what we need to do, and it is very important step, is we have to label degree of freedom. We have to label degree of freedom for each K1, K2, and K3. We have to label based on near and far end condition. We have to label element by element based on near and far end condition. For example, for element number 1, okay, element number 1 is like this. Arrow is like this. So this is near, this is far. Okay, and degree of freedom for element number 1, so element number 1, we call the degree of freedom for element number 1, start from near xy, 1, 2, start from near xy to 3, to far xy. So we call the degree of freedom for K1 as 1, 2, 3, 4. Near, start from near, followed by far. Near, ada X, ada Y. So near XY, far XY. So based on the arrow, we should call the degree of freedom for K1 as 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that is why the arrow is important. We label start from near. When we calculate Cx, Cy, it is far minus near. But when we want to label degree of freedom for each element stiffness matrices, we have to label start from near. Near xy, far xy. So it is 1, 3, 1, 2, 3, 4. 1, 2, 3, 4. If the arrow is, for example, occur in this direction, we put in this direction, we will call degree of freedom start from 3, 4, 1, 2, because we always need to refer to the arrow. So it is 1, 2, 3, 4. 1, 2, 3, 4. For element number 2, okay. For element number 2, the arrow is going towards left. So this will be far, this will be near. And at near, the label is 1 and 2. At far, the label is 5 and 6. So we should call the degree of freedom for K2 as 1, 2, 5, 6. 1, 2, 5, 6. 1, 2, 5, 6. And then we will do the same for K3. We do the same for K3. And K3, based on the arrow, we will call degree of freedom as 1, 2, 7, 8. 1, 2, 7, 8. This is 1, 2, 7, 8. 1, 2, 7, 8. Okay, now we will combine. So it is 8 by 8 matrix. Okay, always remember from K1 until K3. So the label that we put, the degree of freedom label, actually we will refer to the label to produce the structure stiffness matrix. The structure stiffness matrix, which is 8 by 8 matrix, Okay. Okay, it is 8 by 8 matrix, and for the structure stiffness matrix, it will be written in order. In order means we will label, we will write, we will identify the value. Okay, in order from 1, 1 until 8, 8 means that we will have 1, 1, 1, 2, 1, 3, 1, 4 until 1, 8, until 8, 8. Sekejap. It is 8 by 8 matrix, 8 by 8. Okay, the structure stiffness matrix is K1 plus K2 plus K3, and it is written, okay, like this, capital letter of K to represent the structure stiffness matrix. It is combination of K1 plus K2 plus K3. So this K means K equal to K1 plus K2 plus K3. Okay. If we have 4 elements, we have to plus K1 plus K2 plus K3 plus K4. Okay. So all inside this is actually the value that we will get from K1, K2 and K3. Sekejap Tuk Jap dia dah pening dah. Okay, we have to produce 8 by 8 matrix. Wait. Okay, so this is EA over AE. We will find structure stiffness matrix. So this is 8 by 8, 8 by 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So later on, I will paste into the OneNote. Okay, so the position is in order for the structure stiffness matrix. The position is in order. So, for example, for this one, this will be 1, 1. This will be 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. Okay, this is 2, 1, 2, 2, 2, 3, 2, 4 until 2, 8. 3.1, 3.2, 3.3, 3.4 until 3.8. And we do all the same until 8.8, 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8. Okay, so we will put the value. So find the value in K1, K2, and K3 based on the degree of freedom position. Based on the degree of freedom position. We have K1, K2, and K3. K1, 1. What is the value for 1, 1? 1, 1. Can you please tell me the value for 1, 1? Find 1, 1 in K1 plus 1, 1 in K2 plus 1, 1 in K3. Do you get what I mean? 1, 1, find in K1, K2, and K3. So what is the answer?
0.466.
0.466.
Okay, 0.466. Wait. .466. Okay, next value. Next value is 1, 2. 1, 2. So find in K1, K2, and K3. What is the value?
Zero 0.184.
0.184.
184.
0.184. Okay, move to 1, 3. 1, 3. Okay, 1, 3 equal to 1, 3. 1, 3. Do you find do you find 1, 3 in K1? Do you find 1, 3 in, yeah? 1, 3 in K1. What is the value?
0.088.
Negative. Okay, do you find 1, 3 in K2 and K3? Ada tak 1, 3 dalam K1 and K2? Ada tak?
Tak ada.
Okay, tak ada, so ambil yang ada tu je lah. Okay, so we get 1, 3 value from K1 only. Okay, so next is 1, 4. 1, 4, what is the value? Okay, 1, 4, we get from K1 also, it is negative 0.088. Okay, 1, 5. What is the value 1, 5?
Negative 0.25.
Okay, 1, 6.
0.
0, 1, 7.
Negative 0.138.
Yes, 1, 8. Okay?
Negative 0.096.
6. Okay. Okay, since metric is symmetry, you don't have to write 2, 1. So just move to 2, 2 because 2, 1 and 1, 2 will be the same. So just move to 2, 2. Okay, 2, 2. What is the value in total? We get 2, 2 from K1, K2, and K3. So what is the answer? It is 0.088 plus 0.072.
0.16.
0.16. Okay, move to 2, 3. 2, 3. What is the value? 2, 3.
Negative 0.088.
Okay, 2, 4.
Sama.
2, 6. 2, 2, 2, 4, 2, 5. 2, 5, 2, 6.
And 0.
0 and 0. 2, 7, 2, 8. 2, 7.
Negative 0.072.
2, 6. 2, 6 pula. 2, 7. 2, 7. 2, 7. 0.096 dulu kan? Then only negative 0.072. Okay. So move to row number 3. We start from 3, 3 because 3, 1 and 3, 2. Okay, we can get from the previous value, right? Because 2, 3, 3, 2 is the same. 1, 3, 3, 1 is the same. So we don't have to calculate. We don't have to put as well. So we move to 3, 3. Okay, we move to 3, 3. So what is the value? 3, 3.
Negative. No, 0.088.
0.088. 3, 4.
Same.
Okay. 3, 5. 3, 6. 3, 7. 3, 8. Can you find 3, 5 in anywhere in K1, K2, K3?
No.
No.
Okay, means that there's no intersection. We tak jumpa in any K1, K2 and K3, so put 0. Okay, so 3, 5, 3, 6, 3, 7, 3, 8, all are 0. Okay, now move to row number 4. Start with 4, 4. Start with 4, 4. Okay, 4, 4. What is the value? 4, 4.
0.088.
4, 5, 4, 6, 4, 7, 4, 8. Jumpa?
Tak jumpa.
0, 0, 0, 0. Okay, move to row number 5. Start from 5, 5. Start from 5, 5. 5, 5. 5, 5?
0.25.
2, 5. Okay, 5, 6.
0.
0. 5, 7, 5, 8. 0. 0. Okay, move to 6. Start with 6, 6. Okay, 6, 6.
0.
0. 6, 7.
0.
0. 6, 8. Also 0. Move to 7, 7. 7, 7.
0.128.
0.128. 7, 8.
0.072.
7, 8. 7, 8 is 0.096, right?
Yes.
8, 8 is 0.072. 0.072. Okay, wait, I will copy this. Okay, like this lah. It is in terms of AE. Aku di atas pula. Nanti saya betulkan lah. Okay. So it is like this. Okay, it is like this. So yang bawah tu dia diagonal tau. Dia diagonal because matrix ni. Matrix symmetry. So you just need to write like this. So yang ni remain blank je. Okay, so when you write K structure stiffness matrix, so yang part bawah ni remain blank. Tak payah letak any symbol, dia kosong je. Okay, sebab this symmetry, so it is enough to just write diagonal like this. So same goes to element stiffness matrices. You can also write yang ni je. So yang bawah ni you nak buang. Bukan buang, remain as blank because it is equivalent. You get what I mean? Because matrix is symmetry. Okay, matrix is symmetry. Okay, so this is the K lah. Bukan apa, kalau you tulis full, you will put more time to just write K ni, and then you will because you will have many more to do. So jangan put full effort nak produce K, semua ni nak tulis value, no need to do that. So tulis macam ni lah, diagonal macam ni only. And sometimes dalam soalan dia tak sebut pun structure stiffness matrix. Okay, soalan maybe sebut establish element stiffness matrices. Establish element stiffness matrices means K1, K2 and K3. If in the question ada sebut establish structure stiffness matrix full stop, then you have to give in full. Sometimes there is no statement mentioned about structure stiffness matrix, but you still need to establish structure stiffness matrix because when we want to solve for the unknown displacement, we have to have this stiffness matrix. But whenever we want to calculate the displacement, we don't have to consider all. When we calculate displacement, we don't have to consider all. That is why the importance of differentiating or identifying degree of freedom according to unconstrained and constrained, because we have to calculate unknown displacement as the first output. Unknown displacement is the first output, and the second output number 2 is reaction at the support. Means that we have to calculate unknown displacement first, then only we calculate reaction at the support. Remember, reaction at the support all are located in constraint system. So unknown displacement located in unconstrained system. Condition dia akan opposite between unconstrained and constrained. Condition dia akan opposite. Unconstrained constraint. In unconstrained means no support. Unconstrained means no support. No support means nodes 2 can move. Ada pin support means displacement equal to 0. Because of the support, there is no movement. So what we can conclude is in constraint system, displacement is equal to 0 because of the support. No movement because of the support. So displacement equal to 0. And in constraint system, ada unknown reaction. Unknown reaction we label as Q. This is the outcome. This is the goal. This is the objective. Q. Okay, displacement 0 because of the support, and at the support there are unknown reaction, and this unknown reaction are the output, and it is the second output. Okay, in unconstrained, the condition will be opposite. Dia pun ada D, dia pun ada Q. Okay, so D in unconstrained will be the unknown. We call it as unknown displacement. Nampak tak? Dia opposite ya. Opposite. D in unconstrained will be unknown displacement sebab dekat tempat yang tak ada support, node tu boleh move. It can move. So when it can move means there are unknown displacement. So the unknown displacement are the first output. Okay, and Q in unconstrained. Q in unconstrained means because dia opposite, so kat sini ada value. Dekat sini ada value. We call this as, di sini nama dia, kat sini, this is known displacement. Dekat unconstrained is unknown displacement. Yang ni ada things, all these things are the important that you should know. Known versus unknown. Known displacement versus unknown displacement. Opposite condition. Unknown reaction versus, kalau sebelah sana unknown, sebelah sini apa? Between unconstrained and constrained, always opposite. Kalau pada constraint ada unknown displace, ada unknown reaction. So pada unconstrained ada known. Ni important ya. Okay. Ini unknown lawan dia. Known. So this is known. Known. Dia tak sebut reaction lah. Belah sini dia sebut known forces. Because reaction also forces, right? Known forces. Okay, known Q. Okay. Known versus unknown. So yang ni condition ni kena always remember. Okay, bukan remember lah. Yang ni memang you have to understand. Okay, between D and Q. Because after this, kita dah dapat K tadi. And please remember, we use stiffness method, because this is the method that we can use to analyze displacement, reaction, and member forces. In one method, we get all. Okay? Tapi dia ada dia punya step. We have to determine displacement first. Determine displacement, then only we can determine forces. That is why labeling kita start dulu dengan unconstrained. Kita start dulu dengan satu mesti label pada unconstrained. Because in unconstrained ada unknown displacement. And unknown displacement will be the first output. Unknown displacement is the first output. That is why labeling kita label dulu unconstrained. Then only we continue with constraint. Okay, remember this condition. Dia macam ni, contoh kan. Kejap lagi kita nak masuk about force displacement equation or stiffness equation. So stiffness equation that we will touch later is about is actually the important principle that we always apply in structural analysis. Q is equal to KD. It is stiffness equation or it is force displacement equation. So this one is force, this one is displacement. K is the stiffness coefficient. K is stiffness coefficient, so it is called as force displacement equation. It is called as force displacement equation. And Q and D, when we analyze using stiffness method, we call Q and D, we written Q and D in matrix form as well. Matrix form as well means Q is nodal forces and D is nodal displacement. Nodal displacement. Nodal forces, nodal displacement. And we always read the nodal for the force and the displacement at nodes. That is why we call it as nodal. Nodal comes from the word nodes. Nodal. Nodal comes from the word nodes. Node, N-O-D-E, node. Okay, it is nodal forces. It is nodal forces sebab kita akan always baca nilai force pada node based on degree of freedom 1, 2, 3 until 8 tadi. Sama juga dengan displacement. Displacement will be 1 to 8 if based on this example, 1 to 8. So we will have Q1 until Q8, D1 until D8. Okay? So dia punya konsep macam ni. Nanti you tengok juga video yang pagi tadi. So konsep dia lebih kurang macam ni. Macam ni. Okay, for example, sini ada 2 pin. Okay, ada 2 pin. Kat sini ada 2 pin. So dekat sini ada force 200 kilonewton. Okay, 200 kilonewton. Kita nak label based on unconstrained and constrained. In total, there are 6 degree of freedom because of three nodes, 6 degree of freedom. So this 6 degree of freedom, we have to divide into unconstrained and constrained. And the easiest way to identify is by identifying number of unknown reaction. Number of unknown reaction. Tengok diagram ni, identify berapa dia punya unknown reaction.
Aku sebab aku medium.
Okay. So yang ni important. Yang tadi K tu okay. K tu sebab kita follow the formula. You follow the procedure, you dapat K. But unconstrained constraint ni is important especially bila kita nak label Q and D. Because kita nak analyze unknown displacement. Lepas tu kita nak analyze unknown reaction. Tapi kita kena familiar dulu dengan term unconstrained constraint. Okay. Unconstrained constraint. So bila kita nak label, kita nak label diagram ni, kita akan start dengan tengok truss ni, cara macam kita tengok truss sebelum ni. Bila kita tengok truss ni, kita nampak ada dua pin. Pada pin ada dua unknown reaction. So ada dua pin equal to 4 unknown reaction. So 4 unknown reaction ni equal to 4 degree of freedom in constraint system. So ada 4 sini. 4 unknown reaction in constraint system. So bila ada 4 dekat constraint, lagi 2 akan ada dekat unconstrained. 4 ada dekat constraint, nak cukupkan lagi 2 ada dekat unconstrained. So 2 unconstrained refers to unknown displacement D1 and D2, and another 4 pada constraint dia akan refers to unknown reaction which we label as Q3, Q4, Q5, Q6. Okay, means that yang ni adalah unknown displacement. This is unknown displacement. You tolong tengok video pagi tadi sebab saya bagi the definition of D1, D2, D3 in wording. The physical meaning. Tengok yang video pagi tadi. Okay. And Q3, Q4, Q5, Q6 ni, Q5 and Q6, 4 ni, dia akan sambung dari selepas 2 tu. D1 and D2, sambungan dia 3, 4, 5, 6. So yang 4 ni is 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. Okay, so this Q3, Q4, Q5, Q6 ni apa dia? This is the unknown reaction yang 4 tadi. So 4 ni is unknown reaction. Unknown reaction. Actually in total dia ada 6 kalau untuk yang ni lah. Okay, dia akan ada D. Okay, D ni will be written in matrix. D. Q also will be written in matrix. Okay, from 1 to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So in this D and Q ni, okay, displacement, unknown displacement tadi sini D1 and D2, because it is unknown displacement, we do not know the value yet, so remain as D1 and D2. So dua-dua ni lah output. Dua-dua ni lah kita punya objektif, kita punya goal when we analyze structure using stiffness method, D1, D2. So D1, D2 ni belong to unconstrained. So remember at position 3, position 4, position 5, position 6. Yang ni equivalent to apa D tu? 3, 4, 5, 6 ada dekat sini. Ada dekat sini. What is the displacement? What is displacement value at support? At support, what is the displacement? At support. Dekat support, ada tak nilai displacement? Dekat support? Ada tak nilai displacement D3, D4, D5, D6? Ada tak nilai ni?
Tak ada.
Nampak tak yang atas tu D1 and D2, yang tu dua-dua belong to unconstrained. So remaining belong to constraint. Dan between unconstrained and constraint, as I mentioned just now, dia punya condition opposite. It means that known lawan unknown. Nampak tak? Known lawan unknown. So kalau D1, D2 pada unconstrained, D3, D4, D5, D6 pada constraint, unknown displacement lawan dengan known displacement. So sini known displacement. So what is the value? Ada tak nilai displacement pada support? Ada tak nilai displacement pada support? Can move or cannot move? 3, 4, 5, 6. 3, 4, 5, 6. Dekat position 3, ada tak horizontal displacement? Position 4, ada tak vertical displacement? 5, ada tak horizontal displacement? 6, ada tak vertical displacement? Dekat situ, dekat support.
Equal to 0.
Yes, all this equal to 0. It is non-displacement. Sebab dia dekat support. That is why penting you tahu apa dia D3. D3, so this is note number 1. D3 is a horizontal displacement at note number 1. And at note number 1 ada pin support. Pin support means no movement. Cannot move. So D is equal to 0. Okay, so condition dia macam ni. Known versus unknown. Unknown displacement versus known displacement. Okay, same goes to Q. Same goes to Q. Q3, Q4, Q5, Q6, unknown reaction. Unknown reaction is the objective. Unknown reaction is the objective. Second objective. So, unknown reaction or unknown Q versus unknown lawan dengan
Known.
known. So this is known. This is known. Q. Known. So known Q means kena tahu what is the definition of Q1, what is definition of Q2. Okay, refer pada position dalam diagram. Kat mana 1, 2? 1, 2 ada dekat sini. So Q1 sini note number 2 ada Q1 and Q2. 1 and 2 ni refers to the degree of freedom. So Q1 kita refer pada position 1. Q2 refers to position 2. So Q1 equal to what? Q2 equal to what? Q1 is you have to put value because it is known forces, non Q. Unknown constraint dah ambil, constraint system. So this one non value. So what is Q1? Q1 is horizontal force at node number 1. Q2 is vertical force at node number 2. So what is the horizontal force at node number 1? Baca pada node number 1, ada tak horizontal force that is applied into node number 2? So what is Q1? What is Q1? Definition ni saya okey. Definition ni saya tulis wording tu dalam video pagi tadi. Nanti malam saya download, saya letak dalam YouTube, saya akan share link balik. So please watch. Okey, Q2. Q2 yang ni lah, ni Q2. Okay, it is vertical force at node number 2. What is the value? What is the value?
100.
200 or negative 200?
Negative 200.
Negative 200. Okay, this is the most important part because we have to read the Q and D value from the diagram. Kalau you tak boleh identify the right value kat sini, you tak boleh nak completekan the stiffness equation. Kalau you tak boleh nak completekan the stiffness equation, you tak boleh solve the displacement. So you mesti belajar untuk fahamkan condition between constraint and unconstrained, between unknown displacement and unknown reaction, between known displacement and known reaction. Because nanti saya nak you all continue buat yang ni dengan tengok video pagi tadi. Video pagi tadi saya dah completekan sampai last step untuk thrust analysis. Video pagi tadi ni saya stop sampai K because selepas K kita akan masuk ke force displacement, kita akan form the force displacement equation. Okay, yang ni. Sekejap, scroll pun tak jalan dah ni. Macam dah hang je sekejap eh. Saya try open lagi sekali. So what you learn today is how to calculate K and K1, K2, K3 and structure stiffness matrix. Yang ni yang saya suruh you tengok video. Sepatutnya kita terus sambung Q is equal to KD. Tapi tak apa. So saya tinggalkan you sampai K yang tadi tu, structure stiffness matrix. So I want you to continue. Next step is to form the force displacement equation, which is equal to stiffness equation, and it is Q is equal to KD. Q is equal to KD. So Q apa dia? Q is nodal forces, D is nodal displacement. So since we have 8 tadi, yang ni yang pagi tadi 6, 6. So for your example just now it is 8. So we will have Q1 until Q8, D1 until D8. So you have to write Q and D like this. Okay, Q and D like this. So in your case you will have Q3 until Q8, 1 and 2 you have to fill in with value. 1 and 2 you have to fill in with value because it is known forces versus unknown forces. Unknown forces is unknown reaction. And for the nodal displacement, we have D1 until D8, D1 until D8, okay, D1 and D2, both unknown displacement versus known displacement in constraint system. So in constraint system, displacement is equal to 0. So start from D3 until D8, it is equal to 0. So letaklah 0, 0, 0 sampai D8 0. So we write like this. And we combine to have the stiffness equation like this. The stiffness equation. So in your case, you will have 8 lah, 8 by 8, Q1 until Q8, D1 until D8, and you have 8 by 8 stiffness matrix. Okay. However, since displacement equal to 0, because this is just matrix multiplication, line times row. So bila kita nak solve, anything yang kali dengan 0 akan cancel. So kat sini ada 4 0 at position 3, 4, 5, 6. 3, 4, 5, 6 ni. So semua yang 3, 4, 5, 6 ni 3, 4, 5, 6 akan cancel. Tinggal yang dua ni je. So same goes to your condition, your example tadi. So anything yang 3, 4, 5, 6, 7, 8 yang equal to 0 tu, dia akan jadi 0 because kali dengan 0. So lastly, apa yang tinggal is just 2 by 2 matrix. 2 by 2 matrix like this, which we can solve using 2 simultaneous equation. Okay, you follow je step ni, tapi you solvekan yang tadi itulah. Solvekan tadi. So in your case also you will have D1 and D2 as unknown displacement. So dapat macam ni jugalah nanti. Okay, dapat step dia macam ni. Okay, kita akan dapat 2 by 2 simultaneous equation. We write in this form, and when we solve we get like this. Okay, we get like this. So if we don't have AE, doesn't matter. You just can remain in terms of AE for the unknown displacement, because when you calculate the unknown reaction, dia akan cancel AE tu. Okay. So lepas dapat unknown displacement, substitute balik dalam this equation untuk determine Q. Dah ada nilai D1, D2, kira nilai ni. So this is the first output, this is the second output. The first output, the second output. Dapatkan first output, then only you can dapatkan the second output. So second output macam mana nak calculate? Guna multiplication biasalah. Matrix multiplication, line times row. So line times row, you dapat macam ni. So ada banyak video last semester yang saya buat regarding this. So please watch. Yang complete one pun ada. Okay, so you akan dapat Q. Okay, this is just mathematic punya calculation. Okay, so this is Q, unknown reaction, and after that we continue to calculate the member forces. Member forces kita akan remember this formula. So this formula you have to remember, ada dalam textbook. Okay, ada dalam textbook. So saya dah explain pagi tadi how we determine this. Okay, member forces. So kalau ada 3 member, in your case 3 member, you akan ada Q1, Q2, Q3. Okay, yang ni kita pakai small letter because it is member forces. Apa saja yang ada wording member, ada wording element, kita label dia tu mesti pakai small letter. Kalau dia structure stiffness matrix, okay, yang tak sebut M member, tak sebut element, kita pakai simbol capital. Okay, that's why ada yang K besar, ada K kecil. Ada Q besar, ada Q kecil. Okay, so this is the formula. This is also matrix multiplication, so then you akan dapat single value. Okay, this is the basic in stiffness matrix method that you should know. This is for truss only. Anyway, nanti bila masuk beam you will follow the same procedure except formula dia different and 2 degree of freedom for beam component dia Y and Z, not XY. XY is just for truss. Bila masuk beam, it is Y and Z. Okay, so basically truss analysis macam ni je, A sampai Z. But ada effect yang we need to consider. So soalan-soalan effect ni ada example di dalam textbook. Some memang saya dah bincang dalam video. And tengok, nanti kita akan discuss. Tengoklah esok sama ada kita nak buat latihan yang ni balik ataupun kita nak continue dengan three effect, displacement, support settlement, temperature changes and fabrication error. Tengok keadaan esok. Kalau saya tengok you perlukan one full exercise untuk fahamkan ni, kita akan buat exercise. Kalau tak, kita akan continue dengan ni lah, dengan ya 3 effect tu. So basically this is all about stiffness method, yang mana this is compulsory for you to know. Dia tak ada option in exam, this is compulsory. Okay, and this is actually the easiest method compared to the other 2 method, flexibility method and moment distribution method. This is the easiest. Cuma bila you tengok dia first time, you nampak dia susah lah. Nanti bila once you dah faham, you akan nampak yang ni memang straight to the point. Okay, straight to the point. Cuma dia ada konsep-konsep yang you need to clear. Okay, especially yang tadilah about constraint and unconstrained. Macam mana kita nak label Q dengan D, nodal force, nodal displacement. Kalau yang tu clear, so everything will be okay for you lah. Okay, so this is for stiffness trusses. Okay, for trusses. So jangan lupa tengok my video, tengok video-video semua. Lepas ni kita akan ada aktiviti yang you have to do in you future, because saya dah actually register this course under blended learning. That's why macam lepas ni kalau ada saya bagi you activity ke apa, you kena response lah. You kena respond in you future sebab kena completekan blended learning punya evidence. Okay. That's all. Do you have any question? Do you have any question before we end session? So I hope you can, jangan tunggu esok lah untuk completekan yang ni. So you buat malam ni, so you will understand lah apa yang saya explain tadi tu. Cuba tengok video pagi tadi tu and try to complete lah. Dah tak banyak dah, sikit je lagi. Sikit je lagi. Okay. Tak ada soalan?
Tak ada, madam.
Okay. So kena start from now, memang you kena do exercise regularly supaya topik ni you tak lupa. Sama lah, flexibility method pun you kena buat, stiffness method pun you kena buat. Stiffness method and flexibility method, dua-dua topik ni akan masuk final exam, 4 soalan. 2 from each topic. 2 question from flexibility, 2 question from stiffness method. Okay, ada 4 soalan in your final exam. 4 soalan in your final exam. So you have 40% 40% coursework, 10% and 30% test. 10% to assignment. 10% to assignment. So assignment nanti saya akan release combination of stiffness and flexibility method for assignment and test. Your test will be based on moment distribution method. 2 question from moment distribution method. Yang tu masuk minggu ke-11 kita akan rush untuk completekan moment distribution method. And according to blended learning, masa tu nanti kita mungkin tak akan buat formal lecture macam ni. So semua you kena tengok from video, and session dalam kelas kita akan fokus on exercise only lah. Or you can also buat latihan tu outside and then submit dekat OneNote. And kita akan banyakkan buat exercise so that you can buat you punya test. So test kita akan set hujung lah, sebabnya moment distribution method tu topik number 3. So saya target kita akan habiskan topik number 3 tu week 13, so that di hujung week 13 tu is your test 1. Okay? Is it okay? So rest dulu, tapi you have to do exercise, regular exercise for flexibility method and stiffness method supaya you bila end of semester you tak perlu nak ingat everything balik, nak start all over again. Bila you dah buat regular exercise tu, you akan always remember that lah. Okay, so always doing exercise and then tengok juga video-video. And all exercises yang you buat tu please put into OneNote, submit so that I can check whether you do right or wrong. Okay, so thank you very much. InsyaAllah esok you punya kelas pagi ke petang? Esok you petang. Okay, petang okay. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.